Hello, and welcome to How to Realize an Additional 270% ROI with Snowflake webinar. I'm Carol Gunz, Director of Marketing at AtScale, and I'll be the moderator today. It's no surprise that companies of all sizes have embraced the power, scale, and ease of use of Snowflake, along with the promise of cost savings. But as some have learned, cloud compute usage can sneak up on you if you aren't careful. In just under an hour today, we'll discuss how to dramatically increase the ROI of your Snowflake investment with two experts who know how. Our speakers today are Mark Stange-Tregear, who is VP of Analytics at Rakuten Rewards, which was formerly Ebates. He's been with the company since 2014 and was with the team that sold Ebates to Rakuten in 2015. Mark plays a double role, leading a center of excellence analytics group, and product managing the enterprise business intelligence stack. We also have Dave Mariani, the co-founder and chief strategy officer at AtScale. Prior to AtScale, Dave was VP of engineering at Cloud and Yahoo, where he built the largest multi-dimensional cube for BI on Hadoop. Just want to mention today, all participants are in listen-only mode. We do want to open this up for QA if there's time at the end. So please add your questions in the box at the bottom of the screen, and we'll take them at the end of the presentation. And now let me hand it over to Mark. Mark?
Thank you. So welcome every morning. Welcome everyone. Good morning. So my role today, what I'm going to do is just walk through a little bit of the business path that Ebates and then Rakuten Rewards went through to move on to Snowflake. And then I'm going to run through that relatively briefly. What I'm then going to do is get into the details around how we've been managing cost on Snowflake, how we've been managing cost efficiency on Snowflake, and how we've managed to maintain a degree of flexibility and control while doing that. So I think our timeline and our transitions at Ebates and then Rakuten Rewards are not too dissimilar to what many other people have gone through. When I joined the company, we were running our business intelligence off some SQL Server machines. We had SAS out there. We had some MicroStrategy out there. We had some SSRS out there. And the cracks were just beginning to show. We were running on the biggest SQL Server machines available at the time, and we still couldn't handle our workloads. So we were starting to spin up parallel stacks. For those of you that have tried to do that, you know that that comes with some problems. You have to replicate ETL code potentially, or your data ends up in silos. So you've got your marketing data in one place and your sales data in another place and your product data in another place. And your analysts, your business users start to find that to use data, the majority of the time is spent just trying to stitch the data back together and figure out where it went. We were also, even by splitting the stacks, we were running into situations where we couldn't run our ETL loads. We had we were missing SLAs for data that we wanted the morning after it happened, and we were getting it 2 days later. Not an unusual problem. I'm sure many of you have encountered it. Our response, though, wasn't to give up on the data or to just push through that siloed approach. We went down a different road, which is we looked for a clustered computing approach. In 2015 into early 2016, when we were looking at this, there were a few options on the market. We did look at things like Teradata. Ultimately, though, we decided for our purposes, given the way that our company is organized, the way that we like to approach our tech, we would actually try and make a Hadoop cluster work. And we pushed forward with that as we were through 2016. And really, we kept on pushing that to try and work through 2017, 2018, including progressively bigger and bigger clusters. We're buying entire racks of servers at a time to try and just keep our workloads up to speed. It's worth noting at that point that that's where I first got involved with AtScale, running on top of Hadoop. And through all of this, our visualization was Tableau, and that's remained consistent. So by 2016, we were going down the Hadoop path. By 2017, we were fully on Hadoop. We got rid of all of those SQL Server engines. And I think we were in a reasonably good place in 2017. And then the business kept on growing and growing. And more data became available, and clickstream data and API callbacks became much more available. And 2018, we did another huge buy to try and keep up. And ultimately, as part of during 2018, we posed ourselves, this is myself and the head of engineering that I work with, and we posed ourselves the question, like, hey, where are we going here? I mean, are we actually running towards the situation where we're hiring, engineering staff to run a data farm? And we took a long, hard look at the way we've been going, what the options were. And we decided to at least experiment with the new cloud databases that were coming up. They've been around for a while. I'm not trying to claim we were on the cutting edge of this. We did have legacy platforms we were dealing with, but we decided it was time to give them a real shot. Part of that was also paired with the fact that Rakuten Rewards was moving a lot of its other functional stack onto the cloud. So it was a decent time to do that. We were a little ahead of everyone else, but only by about a year. With respect to the internal company workings. And at that time, late 2018, we went through a multi-step side-by-side comparison of the big vendors. So think Redshift, BigQuery, Snowflake, etc. What we ultimately decided, and this was a decision that worked for our company, I'm not necessarily saying that it's the right decision for everyone by any means, but we decided that by the time we looked at some of the core issues we were having and some of the core things we were trying to solve, including can we load the data fast enough to get close to real-time data? Can we hit our SLAs? Can we remove the issues with multiple concurrency that we've been getting on Hadoop? The Snowflake presented the best solution. And in late 2018, we went to a large scale POC on Snowflake, including running some production workload on there, just not all of it. That was so successful and it worked so well that during 2019, we migrated our entire stack into the cloud and onto Snowflake. So before Q4, we tend to think in terms of quarters, and with Q4 being the big one because I work for a commerce company. But before Q4 2019, we were fully migrated onto the cloud and onto Snowflake. No Hadoop left. We shut those servers, let them run a little bit in the background, eating some electricity just to be on the safe side for a couple of months, and they were all shut down before the end of 2020, much to the delight of my operations and tech team. Since then, we've moved we routinely run about 70,000 scheduled jobs a week on Snowflake. That's independent of any custom SQL that analysts or data scientists are writing. And we're getting a failure rate somewhere around 0.02% on any given week. And usually that's actually not to do with us, and it's bad data format coming in from other providers. So overall, we're very happy with the migration. This phase 3, as we like to think about it, from SQL into Hadoop into Snowflake is well underway and has been very satisfying. Can we move to the next slide, Dave? What were the biggest tipping points? I think the biggest single tipping point for us was the issues around concurrency. With the Hadoop cluster, we could isolate CPU, we could isolate memory, we spent a lot of time trying to tune jobs and trying to isolate workload, even trying to block workload so that it didn't interfere with other things. And we had some success with that, but ultimately we even found that the hard drives couldn't keep up. Right, we were writing so much data to disk to try and power real-time tight workloads that we couldn't get the data back off disk fast enough to actually service our end users. What that was meaning is that our SLAs, it was a little bit like playing whack-a-mole. The minute we tuned something else slowed down, or a user would write a query that jammed one of the hard drives, or some other kind of cascading failure. And whilst Hive and in particular Impala have got stronger over the years, we were just finding that we were spending most of our time not doing business and intelligence. Even my analysts, even the analyst side of the team, never mind the engineering side of the team, was spending most of their time trying to debug the issues between the application and the hardware layer. So that was leading, as the slide says, a lot of frustration, missed goals. We were missing SLAs. People couldn't get the data they needed. And that was one of the key issues that with Snowflake we looked at. Can we get to multiple concurrency and much better control and visualization of what workload is happening, how it's happening, and make sure that it doesn't interfere with each other? That was probably the biggest single goal for us in shifting to the cloud. There were other distinct advantages. For those of you that know the Snowflake platform, their data sharing concept is pretty revolutionary. We use that a lot. I'm not going to spend a whole lot of time on that, but that was definitely a pull as well. We also like the fact that the UI looked very familiar to analysts and data engineers. We didn't have to deal with a whole lot of security because their security is really robust. There was a variety of different reasons, but I think if you had to pin down one, it would be the multiple concurrency and the ability to handle all kinds of different workloads without having to separate the data out. And one thing just to make clear before I go any further, we don't separate our data lake, our data warehouse, our data marts, whatever you want to call it, right? We our analytics layer. All of that data resides in Snowflake, and it's all just in different schemas. That means that we don't have to jump through hoops in terms of trying to blend the data from different levels of granularity across different surfaces or different systems. All of the ETLs are running on the same place. All the data's in the same place. So if you're working with a data mart table and you need to join it back to a data lake table because you need more granularity than is in the data mart, no problem. You just join it across, and you can do it in a single SQL statement. In terms of the ability to power data use and analytics, that is enormous. We just eliminated so much wasted time trying to blend data and trying to manage data. And that was another huge win that we got here, just because of the scalability of the platform. All right, let's move on to the next slide. Okay, to the cost. So I'm going to start a little bit with the principle that we had in mind as we transitioned into Snowflake and as we saw the way that they had separated storage and compute. And what I mean by that is that all of your data in Snowflake, for those of you that don't know, is stored centrally. Anyone can access it as long as you have the right permissions. But the notion of warehouses are effectively separate processing clusters. They come with their own CPU, they come with their own memory capacity. We realized pretty early that more warehouses was going to be really helpful, because what that meant we could do is we can isolate workloads. The initial concept of this was, if I give a warehouse to the marketing team and they run some really nasty, super heavy SQL, they're not going to interfere at all with the sales team trying to run their day-to-day sales analytics if they're on different warehouses. Not going to interfere. It's a separate set of memory and CPU, and it's kind of up to Snowflake, and in our case, Amazon, to manage the storage. So we rapidly, very rapidly, and this we did very early in the process, is that we started creating a lot of distinct warehouses. We've got multiple per business team. The sales team have, I think, 6 at this point. Every engineering group has their own distinct ones. And for my team and the teams that write ETL, we have separate warehouses to handle individual ETL components or types of ETL workload. Another huge win is that we put individual warehouses out for third-party products. In our case, this is products that connect directly to Snowflake to use our data to do other things. Message gears, Ally, Segment. We use a couple to do different things. I'm not going to go into that too much right now, but these data armor, but these systems can connect directly to Snowflake and pull data in. it's a huge advantage, right? It makes the data, the notion of having to move data around really, really easy. What we found very quickly, though, is that having those services on their own warehouses was very helpful. And I can explain why as we go through the next couple of slides. Another key thing that we didn't give the teams the control over their warehouse sizes. What we did instead is that we worked on the basis of giving multiple warehouses to the individual teams, often multiple different sizes. So we give the sales team a small, medium, a large, and then, but we don't give them any control over the size of the warehouse. Why? Well, for any of you who have talked to some people who've tried to handle Snowflake cost management in the past, you may have heard horror stories where, a company put whatever amount of money down, bought some Snowflake credits, and then handed over control of warehousing sizes to their analysts, or, and I'm not trying to pick on data scientists here, they're data scientists. And what happens? Well, there's a slow running query, or they really need to run through some heavy data or some heavy analysis. So they crank it up to an Excel, a 2XL, a 3XL, a 4XL. For those of you that don't know, the cost structure for Snowflake is doubles for each increase in size. So using a 4XL is twice as expensive as a 3XL, and is many, 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 I guess I should have done the math, times more expensive than using a small. Maybe not a problem if you've got a very deliberate workload, you do it on purpose, and then you shut it, and then you move it back down again. But if you allow teams to just scale their warehouses however they want, what happens over time is they move to 4XLs to try and push through workload, and they don't tune them back down again. And now you're paying a small fortune for workload that could be executed vastly cheaper. So what we did is we created a centralized cost management and oversight team. It's a relatively loosely held team. It's not like I'm part of that. Everyone else on there has other day jobs, including our CFO. But effectively, we centralized overview of cost management and warehouse size. Now, I was able to do that because of my organizational structure. That may be harder for some others, but it really paid dividends because it put us in a position where we didn't really get runaway costs. The other thing we did is we put a kill switch on queries. Basically, if anything tries to run longer than 2 hours, it just kills it. And we basically say, if you're genuinely trying to operate on a workload that takes more than 2 hours, come and talk to us and we'll help you tune it. Or we'll find a way to run it if you absolutely have to do that. We've never had a situation where we've needed to do that. It's as simple as that. Usually, or in every case, we've managed to find a way around it. Okay, so we've got a lot of warehouses out there. We've got centralized control of the sizing, right? Just as you would do with expense reports or something. You don't just allow anyone to spend whatever you want on the company's dime. So now what? Is bigger always better when it comes to warehouses? No. And this was an interesting learning for us. We have found that managing warehouse sizes actually becomes a little bit of an art/science in and of itself. If you're finding that you have a workload that is primarily just about bringing data off disk or writing data to disk, you can probably run it on a very small cluster because there isn't actually much compute power needed to do that. You're just waiting for the storage, effectively. It's not quite as simple as that, but we've found multiple workloads where we've been able to significantly downsize the size of the warehouse that a job's running on, save money, and it executes in almost exactly the same time, or no perceptible difference. Going the other way, big aggregates, and in particular, big joins take computing power. You've got to bring the data, you've got to then mush it together. You need CPU and you need memory to do that. And it is not a linear process. We've also found situations where we have increased the warehouse size and actually saved money despite the fact it's running on a bigger warehouse, because the job will complete so much faster that it actually pays for itself in terms of the cost per hour. So for example, if we had something running on a medium and you step it up to a large costs twice as much as a medium for an hour, but we've had, if the job takes the same amount of time, you're paying twice as much. But we've found that we've had situations where we've moved jobs from a large to a medium to a large, and the time saving has been, say, 75%, at which point you've actually paid less for the job on a large than you would have on a medium, even though it's running on a more powerful warehouse, and you've just chopped your time to process by 75%. Does that work in all cases? Absolutely not, right? And that's the 4XL problem I mentioned earlier. If you just assume that throwing bigger warehouses at everything is going to help, you've got a problem. It's going to cost you a lot of money. All right, let's move on to the next slide. Okay, so we've got all these warehouses. We understand that it's a little bit of trial and error, a little bit of an art and a science to actually get these warehouses to do what you want and to manage costs down. How are you going to do that? Well, I think a game changer for us in this space is, I'm an analyst, that's my background. So very early in the Snowflake engagement, I think one of their sales engineers or one of the tech contacts we were working with, we were trying to figure something out, and he pulled up the metadata tables and was like, hold on, let me see how long this particular query ran. And I was like, what did you just do, right? Are you telling me that all of my job data is in there as metadata and just queryable? It was like, yeah, sure, it's just here. And my brain immediately went to, what else can I get from here? And started looking for the potential of what I could do with that. Now, a lot of you on the call may be, wow, you were slow to pick up on this. I knew this from day one. Good for you. I wish I had. We found this very early, actually, before we really went into the full POC. What did I do? Well, these are just data tables. I hooked it up to Tableau. Right? I can now visualize all of my costs and even my query level data within Tableau. And more than that, I can pull standardized reporting, and I can send it to a subscription list of users who need to be keeping an eye on it. Referring back to the team I mentioned earlier about cost control. Using the metering history and the query history, we literally built out Tableau reports on a daily basis, show what the workload is on each of our warehouses. And of course, because we associated the warehouses to the teams, we know which team is generating how much workload and therefore how much cost each day, right? The chart on the top left there, the rows that are blanked out would show our warehouse names, and the bars are the cost of the days as you go across. So you can look and you can see the very top one there is a business unit. You can see it fluctuates up and down. The peaks there are Wednesdays. I don't know why they do more work on Wednesdays than they do on Tuesdays and Thursdays, but they do seem to. The Saturdays and Sundays are pretty obvious. They're the low points, right? There's still some workload going on, but not nearly as much, right? This allows us to detect day-by-day spikes in activity if the users do something weird, or if there is an unusual burst of activity, we can spot it. If you can get the data by day, you can aggregate it to the week and look at the longer term patterns. And that's the chart right next to it. So again, same thing, each individual row represents a warehouse, or we sometimes group the warehouses together to the business unit. You can see about, whatever that is, 8 rows down there that we had one particular warehouse that was sort of running at a very flat amount of workload, suddenly started spiking, and then you can see it drops off a cliff. Why? Because we saw the spike coming in on the daily report, went in, figured out what the issue was, retuned the code, and eliminated, I think that one was about 75% of the cost. It was a little difficult to tell this zoomed out, but you know, we just wiped out costs by re-engineering. Could we have done that if we didn't have the warehouse visibility? Almost certainly not, because that spike probably wouldn't have been visible. And even if it had been noticed, like if we just had all of this running on one huge warehouse, how would we have pinned it down? I mean, it'd be nigh on impossible at our scale. So that allowed us to go in and sort of pinpoint tune. We also keep an eye, you can see over on the right there, we calculate the annualized predicted cost on the warehouses so that we can get a sense of where we're spending most of our money. you know, that's basically just an extrapolation from the cost per week and cost per day charts. Just a quick reminder, this goes to automatically into my CFO and the oversight team on a daily basis. So if you do have a situation where a particular workload's growing, a particular use case is growing, or where we feel like a particular team is spending maybe more than we want them to be, or we're surprised, that's immediately visible. We pick up on that typically the day after and can take remediatory actions. Down at the bottom there, so all of that, all of the top section comes from the cost metering, right? And this is just a drop in the bucket. We have several layers of drill down below this. I just couldn't fit it all on the slides. Down at the bottom there comes from the query history. The rows again show the individual warehouses that we're dealing with. These are and then the different bars here show the stats. How many queries are running on that warehouse? How long is the average query running? What's the compilation time? How long Snowflake takes to put together the SQL? How long is the actual execution time per query? What's the queue time? And that's an important one. If you try and throw too much workload at a warehouse and it hasn't got the compute power, it'll just start queuing. You can, in some pretty egregious situations, you can end up queuing for significantly longer than it takes the job to execute, right? And there are things you can do about that. So I think the overall point to take away is, if you want to manage Snowflake costs, get very familiar with those metadata tables as quickly as possible. And I would recommend visualizing them in this kind of way so you can spot hotspots. All right, thanks, Dave. Let's move to the next slide. Okay, I have not got time to go into all of the depth on here, but I did just want to put this out because a lot of content, there's a lot of potential things you can do. Once you've got the structure in place, have multiple warehouses, and therefore you've got the visibility, you've got multiple different levers you can pull. And the advantage of having the multiple warehouses is that the levers are relatively easy to pull, and you can isolate the workload that you need to do something about relatively quickly and easily. So what do we do? And these are roughly ordered in terms of level of complexity or difficulty. So shifting the warehouse size up and down. If you have a warehouse that doesn't have a ton of workload, it's sitting on a large, but it's costing you more than you want, try tuning it down to a medium. Doesn't mean that that the jobs will necessarily run any longer. It really doesn't. And if you've got a lot of jobs that are focused on I/O, there's a good chance it won't run any longer and you'll just halve your costs. Sometimes you want to move them up. Like I said, it's rarer that we find that that's the right approach, but we have done that. Horizontal scaling, that goes back to the queuing point. Snowflake will add clusters. So if you're trying to run a certain workload through a medium cluster and a whole bunch of new requests comes in and Snowflake starts saying, I can't process this workload, I need more compute power, you have control, or you have some degree of control over whether it will stand up another medium cluster to deal with that workload. Basically, you can set it to really don't do that unless it's an emergency, or do that relatively aggressively. What we've found, again, is that this one's a little bit counterintuitive, but giving Snowflake the ability to scale horizontally more easily can actually cut costs. You would think it would add costs because now you're running two warehouses where previously you were running everything through one. But what we found, again, it's not a linear relationship. And sometimes allowing the warehouse to scale out allows it to move a lot of that queued workload very, very fast and shut the second warehouse down much sooner than you could do just waiting for it to all process through one warehouse, and you actually save money. Another thing you can do, if you've got enough warehouses, and we do this we do this multiple times a week, is we move particular jobs between warehouses. So if you have a small, a medium, a large, an extra large, and you think, this particular workload is costing us a little bit, let's try moving it down to a medium. So you don't change the warehouse, you run the size of the warehouse that the particular jobs are moving on. And in particular for big ETL loads, we've found that can be vastly beneficial. Caching. Another one, Snowflake will cache data within warehouses. So if you have very duplicative workload, you want to consolidate that onto a warehouse. And this can get really interesting because you can actually offset some of the cost of a larger warehouse because of the caching. So that points in exactly, there's another situation where potentially moving up a warehouse size can actually save you money, because while you're powering more workload with one warehouse, because it's all using the same data, you can actually save on I/O time and therefore cut your costs overall. 5, code rewrite. Right. You can get, everyone's got some badly written SQL out there. I know we do, you know, Cartesian joins, etc., that then get filtered down. There's usually, if you really want to, you can often tune workload. And again, we do this routinely. Obviously, that's not trivial, especially on important jobs, but it can lead to big benefits. And the final, I'll come back to that in just a minute on data modeling. And the final one is around clustering. You can put custom clusters on Snowflake data, particularly on very, very big data sets. If you know specifically how you intend to query them in most cases, we have had some success with that. We don't do that lightly though. We've rarely found, except on extremely large data sets where we know exactly what we're going to query on, it hasn't really paid for itself, because to use clustering, you do then have to pay for Snowflake's auto clustering processing. So you sort of add a cost. You've got to make sure that the corresponding savings actually pay for the cost that you add in the auto clustering. So I don't use that one lightly. Just jumping back quickly to the code rewrite, and this is where Hadoop has a lasting place in my heart, is the importance of data modeling. You know, Snowflake's super powerful. If you have the raw data in there, in data lake tables at super granular level, and you throw a 4 Excel warehouse at it and join an aggregate to your heart's content, it will process it. It's just going to cost you a lot of money. We've found a lot of situations where it is much more efficient to do a few joins, a few aggregates up front, produce that, rewrite that job, the output of that job as a table. Think of it as like a big flat data warehouse table, and then just query off the data warehouse table. I find it difficult to quantify what that has saved us, but I would put it in, you know, a meaningful percentage of our total cost savings are just by doing that. And that just underlines the fact that joins, aggregations are inevitably expensive. So if you can anticipate what is needed, where it would be happening multiple times, do that once a day or once every couple of hours, and then power most of your workload off the pre-joined, pre-aggregated tables, you're going to save a small fortune over time. And I think, Dave, that's an appropriate place to point it over to you.
Great, thanks, Mark. That's great. And so that last one about the flatten the warehouse tables and the aggregations, that's going to come up in a lot in the content that I'm going to cover today, and in the demo. So keep that in mind, because that is a very powerful concept, and we'll be able to show you and quantify exactly what that means here today. So you know, Mark talked about a lot of things, and when it comes to controlling costs and managing your environment. And a lot of the cloud data warehouse vendors, you know, they kind of hold to their guns here that, hey, you know, we're always fast enough, and we have endless capacity and compute, so don't worry about it. But really, that's, you know, there's always a catch. And when it comes to thinking about the kind of cloud data warehouse that you want to go to, you need to really be thinking about these 4 different dimensions. When it comes to query performance, that's just raw. How fast can a single query get executed and come through? The different cloud data warehouses have different latencies for queries. And that's really important when you're considering it. Snowflake has pretty low latency, and it's very strong in that department. User concurrency. You would think that in the cloud with endless compute, that user concurrency wouldn't be a problem. This is definitely a problem, and definitely something you have to manage, because like Mark mentioned, you know, the way the cloud data warehouses typically deal with too much concurrency is by queuing. And by queuing, you're basically putting queries in a line, and users don't like that because that becomes very unpredictable. Mark talked a lot about compute cost, and of course that's super important. And then the semantic complexity is also important. So Mark mentioned the importance of data modeling. And data modeling is very important. And creating a data model on top of your cloud data warehouse like Snowflake is gonna really pay off in multiple ways. So, so what does the cloud stack look like these days? You know, usually in most cases, and I think in Mark's case, this is AWS. Data lands in AWS and lands in S3. And then there's some kind of ETL process that then copies it to the warehouse or loads a warehouse. That happens to be Snowflake in Mark's environment. There may actually be consumption straight off of that data lake. In Amazon, you have tools like Athena and Spectrum that allow you actually to tap straight into that data lake if you want. As Mark mentioned, he's been able to do that entirely with the data warehouse in Snowflake and avoid sort of access to that raw data. You have a data catalog that's typically sitting along the side. A lot of people may have custom ones they do in-house, or you may be using a Alation or a tool like Calibra to manage that. And then also, you obviously have all your consumers up here. Your consumers may be Tableau as a BI tool. It may be your data scientists using their Jupyter notebooks, consuming data. It may be custom applications that you build for your partners or your internal users. The real key thing here is this universal semantic layer. And that's what we're gonna really be talking about, because by having that universal semantic layer, you get a couple things that come along with that. In AtScale's case, you get a full multi-dimensional engine that makes your users makes their life much easier to understand, and also gives them consistency when it comes to metrics and business definitions. You have a single point of entry to apply data governance. And you can apply data governance either at a logical level or at a physical level by having this semantic layer. And then you obviously virtualize and hide all the physical implementation of the data. So the people who are consuming it don't know whether it's coming from Snowflake or from a data lake or from MySQL or Postgres. You know, you have lots of legacy data sources. You don't need to migrate those all to one. If you have a virtualization layer with a semantic layer. So a little bit about the semantic layer. So why is it so important? What you see over here on the left is the semantic layer for TPC-DS. TPC-DS is a benchmark that has been sponsored by the TPC Council, and it's a typical retailer's kind of a schema. Now with that, you know, you can either write really complicated SQL, which you'll see in a second, or you can use a multi-dimensional model like you get with AtScale that makes it very simple and easy to consume. By having that semantic layer, now you have a single source of truth. So at Yahoo, we ran the business on page views. And I can't tell you how many different definitions of page views that we had, and it was all tied to the individual BI tool that was being used or the report that was being authored. And it's crazy that a simple statistic like that could have so many different definitions and ways of explaining it that drove Jerry Yang, our CEO, and my boss crazy. And then obviously it's governance for all. If you have a single sort of door into the access to your data, it gives you the ability to centralize that access without having to apply that access and those rules and those ACLs at the individual BI tool level. So what about the simplicity? So what I'm going to show you today is that this is an example of the TPC-DS query. And this is query number 33. And I'm going to use this for my demo. And basically, it's asking for, I want monthly sales for a specific month and a year for manufacturers for a certain category in a given time zone. And I want to group those by my manufacturer and then sort them by the amount of sales and by channel as well. So a typical business type of question. Now, what you see on the left over here is the AtScale SQL against that TPC-DS business model, or AtScale virtual cube model. It's pretty understandable, pretty easy to read. What you see on the right is what the TPC-DS raw query would look like. And this goes on and on and on. And I'll show you what that looks like in a minute. But you can obviously see the difference in complexity when it comes to having a layer versus not. So let's talk a little bit about this benchmark. So why do we do this benchmark? Well, we did this benchmark because, again, we wanted to measure along those 4 different dimensions of scale. Query performance, concurrency, cost, and simplicity. And we've done this for all the major cloud data warehouses. So Snowflake, BigQuery, Redshift, Synapse, and we're doing one right now on Databricks. So if you come to our website, you can see the results of this test. Now, these are expensive tests because we have to stand up a 10 terabyte instance of each of these vendors. And then we have to run a suite of tests along pretty large data sizes. So you can see we have a multi-fact model here because we have store sales of almost 29 billion rows. We have web sales of 7 billion rows, and we have catalog sales of 14 billion rows. And we have big dimensions. So we have big dimensions like a customer, and customer address. We have an inventory dimension. So when you join all of those together, you get what Mark was referring to. You get lots of joins against big data, which really drives up your costs and makes your performance very unpredictable. So we took and we measured for each of the cloud data warehouses. And what I'm going to present to you today is the results of our Snowflake test. So what you see here on the left is the TPC-DS 10 terabyte test that we ran against Snowflake raw. Now, the great news with Snowflake is that you have the 10 terabyte sample data set as well as a 100 terabyte TPCS sample data set, right, that comes with your Snowflake instance. So we were able just to run straight on top of Snowflake, and they created those tables for us in a data share. Now you can see that with and without AtScale, we're talking about 14 times faster. So this is running a suite of tests, and this is the amount of time it took to complete the test with and without AtScale. So without AtScale, it took 127 minutes. With AtScale, it took 9 minutes. So why was that? Well, if you look at our concurrency test here, you can see that we ran concurrency tests with 1, 5, 25, and then 50 threads. And that means that taking those TPC-DS queries and running them concurrently in this case with 50 concurrent queries. And we disabled caching so that we could get a true test of what that concurrency would look like. And you can see that with just running raw, you see it roughly with each sort of orders of magnitude, it pretty much linearly goes up in time in terms of execution time. So in other words, the 50 group took almost little more than twice as long as the 25 group. And the 25 group took about 5 times as long as the 5 group. So that's what I mean by concurrency. You cannot take that for granted because more users on the system, even though it's a cloud data warehouse, does not mean that you're going to get consistent performance. Now, if you look at using AtScale, where we've used aggregates, where we've made the queries run fast and access substantially less I/O, we can mitigate those typical problems you have with concurrency. You can see that there's almost no change in AtScale's runtime as we added more concurrent users. Now, what about cost? Well, cost is another factor. With cost is like, and we measured this cost by the time it took to run the queries. And with AtScale, we were actually, and Mark touched on this, we actually were able to use a small cluster compared to the raw run on the Snowflake raw side, where we ran on a 3XL cluster. So big difference in cost, both on the size of the cluster we used and the amount of time we took to execute the test. So last slide, and then we'll get into the demo. So what does this slide show? Well, you can see that this was, if you go to Snowflake and you go into the warehouses screen, you can what the activity is. Now, the orange bars indicate queuing. So, and then you see over here, you see the warehouse load over time. So this was the beginning of the query of the TPC-DS set of suites, and this was the end. And you can see here that we ran them for all the four thread groups. And you can see that in the peak case where we have a peak queuing, you can see that almost 42 of the 50 queries are being queued, which means we're only really running less than, about 8, well, in this case, about 5 queries concurrently. So that means those other queries are waiting in line, waiting to get executed. Now, if you look at the AtScale scenario, for the exact same run, except we also added a 100-thread test. So, so we did more work. And we were able to use a small warehouse, and you can see that the warehouse load was a 0.9, substantially less. And obviously you see no queuing here because these queries all run fast and quick. So in sort of conclusion here, you can get a 270% ROI, and you can see here along these different times and these are our 4 different dimensions of measurement, that we can run 4 times faster on a simple raw 1 query test. We can give you 14 times faster queries if you run with concurrency. And we're gonna make it 73% less expensive while making your queries 76% less complex. So we don't have much time to go here, so I'm gonna do a very quick demo, and I'm gonna compare the AtScale queries here that you see here. But before I do that, let's go back and let's go into Tableau. And I want you to see, well, first of all, let's go into Design Center, AtScale's Design Center, and here is the TPC-DS model for Snowflake. So you can see that we have our multiple facts, and we have our dimensions in green and in gray. In Tableau, you can see our preview. We have nicely organized metadata in folders, very easy to understand without having to understand or write SQL. So let's go ahead and let's run against this 10 terabyte. Remember, we're dealing with 52 billion rows here. And let's start with our sales in our store sales. So let me give you the number there. So there's our 28 billion rows for store sales. So I'm going to go ahead and replace that with my quantities sold. And these are all running, this is all live queries against Snowflake. It's not cached. And you can see we have 1.3 billion items to deal with here. So let's just start with our dates. So I have a bunch of different date hierarchies here. You can see I have my inventory dates, I have my return dates, my ship dates, and I have my sold dates. And I have a hierarchy. So you can see I have month, quarter, and year, and date. So all I need to do to use that, for example, is just to go ahead and double click on my sold calendar year, and voila, now I have my data that's my sold, quantity sold by year. Let's keep peeling the onion and let's look at our product dimension. And our product dimension has a hierarchy. So let's look at products by category. Again, This is all a live query against our warehouse. So here we go, and there's my product categories. Let's zoom in on sports today, because that's pretty much the only thing we can do during quarantine. And let's look at my product class by sports. So let's look, and we'll break those down. Again, running live queries against my warehouse. So here's all my different data. Of course, TPC-DS data is all manufactured. That's why it's not, I can't tell a story with the data. What you might want to do is you might want to look at golf, for example, and then look at demographics by golf. That's all part of the model. So I can look at my income band just by double clicking on that. And now I can see if there's only rich people who play sports. And if I go to my totals here, you can see I was dealing with 8 billion items that I counted up. So what's the secret behind all that? I'm going to go back into Design Center. I'm going to show you my queries, and I'm going to show you my query log here. And I can see those queries were all hitting ads. So here's that last query. This is the query that I actually, that Tableau generated. That's what I used for my TPC-DS test. And you can see here's the query that we generated against Snowflake. And the key here is that we substituted an aggregate table in place of that raw data. And that's the secret to how we actually make that happen. So, and that if I look at that definition of that aggregate, you can see there's 23,000 rows. So it's going to be fast, and it's going to be fast every time. AtScale manages those aggregates and keeps those aggregates up to date. It does it automatically, all behind the scenes without any manual data engineering. Okay, let's go back to that query 33. And let's first go to my AtScale version of TPC-DS 33, and I'm going to run that through AtScale there, and I'm connected this through JDBC, and now I'm running a raw query using this this little tool called DB Visualizer, and you can see my query ran in about 2 seconds. Let's go and run the same query and go to my my console here in Snowflake, and let's run that, query through. This is the TPC-DS query. So as that's running, what's going on here? You can see that I have store sales, I have catalog sales, and I have web sales, and it ran it in 11 seconds. So not too bad. Except if I go to my history over here and I look at my history, let's look at, let's do a refresh of that. What I can see here is, let me refresh this again. I can see what my resources were here on this particular query. And I can also run that and get this data straight from my system tables too. So there you go. That last query was 4 gigabytes of bytes scanned, and my query, my AtScale query, was 76 megs scanned. So what's 4,000 divided by 76? It's 52. So 52 times less data read for the same exact query, which is much more simplistic than what you've seen. And Mark, and the way that I can go and actually run that and get my usage statistics is I can just run this right against this usage count history, and I can get my actual data here, and I can see my elapsed time, my byte scan, my compilation time, and credits used. So here's the difference between those two queries. It's already pretty cheap to run the other one, but look at this. It's even off the charts cheap to run the AtScale query. So that's kind of how it all works. And I know it was quick, but just to wrap it all up here, and so before we take some questions, if you'd like to, you can get all this data, including the Snowflake benchmark report. You can also, if you want to compare the different data warehouses together, you can do that. Just come to our website. We can save you a lot of time and money from having to do these tests yourself. You can also read the Rakuten Rewards case study. Mark has been a great customer with us for a long time. He's seen it all, and you can learn a lot from his experience. And pretty soon we'll be introducing a cost estimator, so you can see just how much money you can save with AtScale on Snowflake. So thanks, guys, and Carol, I'll hand it back to you for Q&A.
Well, thanks so much, Dave and Mark. Great presentations today. We do have some questions from people. Dave, let me just ask you first. How do you compare the Cloud Data Warehouse benchmark for Snowflake with, say, Google Cloud, AWS, or Azure Synapse?
So you might get me in trouble here, but like I said, you can come to our website and you can see the raw numbers for yourself. But Snowflake was the overall winner when it came to speed and cost. So it's a great choice, and Mark made a great choice.
Okay, thank you. Mark, you referred to a team looking at costs. Who is actually watching the costs of Snowflake at Rakuten Rewards?
Yeah, so right now it's a relatively small condensed team centered in the kind of the group of, as I would say, expert users along with the engineering leads for the company, but it's also business leads. So there's myself, head of engineering, one or two other analytics folks who are specialists in tuning queries, but also the CFO, and the data is visible to a couple of our GMs as well. So the day-to-day practical answer is that my team does a lot of the work in terms of actually tuning the warehouses up and down, but from an oversight, visibility, and sort of overall strategy point of view, that goes up into the C-level for us.
Yeah, that's great. Dave, this one's for you. How long did it take to build the aggregates on the 10 terabyte data set?
Yeah, that's a great question. The cost numbers include the building of the aggregates, by the way. So we didn't cheat by saying, it does cost compute to build an aggregate. In Snowflake's case, the aggregates completed in under 2 hours. So somewhere between I forget the exact number, between 1 and 2 hours, but under 2 hours. And those aggregates, that was from building it from scratch. So as data comes in, with AtScale, you can incrementally update those aggregates. So you're only going to be paying for the cost of the delta of the new data, and you're not going to be recomputing history over and over again.
Great. Let's see, Dave, another question for you. Does AtScale create and store cubes as part of ETL?
So with AtScale, we call them virtual cubes. They're virtual cubes because there is no cube building process. What we instead do is we build aggregates to support those queries and the query performance based on user query behavior. So you can think of it as that virtual cube that you saw was all pure metadata, it's just XML. Where we intercept those queries, we figure out whether it makes sense to build an aggregate and keep that aggregate around, and we'll do that automatically as part of that query process. So it's all behind the scenes. There is no ETL that's required or manual data engineering to build those aggregates. It's AtScale's job to compute and figure out whether an aggregate is going to be useful, and then to keep that aggregate up to date as new data comes into your Snowflake environment.
Okay. And then I think we've got time for one more question today. I guess, Dave, do you support nonlinear calculations like percentile, standard deviation in AtScale working with Snowflake?
That's a great question. Those typically are, those kinds of calculations are typically harder to do in raw SQL, and it's where our OLAP model and our OLAP engine really comes into play. So semi-additive metrics, level metrics where you have different totals for different levels of your hierarchy, time intelligence, which is all rolling averages, cumulative averages, cumulative totals. Yes, all those are covered. So standard deviations, you name it, windowing functions. With AtScale and with the OLAP model, we can do much more complex business calculations without forcing the user to write complex SQL.
Okay. Well, thank you so much. We're up against the hour, so I want to thank everybody for their time today. And thank you again, Dave and Mark, for your great presentations and demo. All right.
Thank you.
Goodbye,
Thanks,
everyone.
everybody.